Right now, even if you are sitting in a room with the lights turned off and the curtains drawn, you have never seen real darkness. Your brain is currently engaged in a localized planetary illusion, an interpretation of reality shaped by biological systems that evolved to navigate an African savanna, not the vacuum of the deep cosmos. As you sit there, your pupils are dilating, expanding to their physical limits, to drink in every possible stray photon. The rod cells in your retina are shifting into high gear, amplifying the signal from the subtle glow of electronics, the faint light leaking through the gaps in the door, or the distant invisible hum of city lights reflecting off the atmosphere miles above your head. On Earth, darkness is not the absence of light, it is simply the presence of very little light. We live at the bottom of a thick, protective cocoon of air that continuously bends and scatters radiation in every direction. Even on the most remote mountaintop, far from the nearest street lamp, you are still surrounded by a faint, permanent luminescence called airglow, a ghostly light emitted by atoms in the upper atmosphere that were energized by the sun during the day and are now slowly releasing that energy back into the night. You are surrounded by zodiacal light, a cone of radiance caused by sunlight bouncing off dust particles floating between the planets. You are living inside a domesticated version of the night, softened and filtered through layers of earthly interference. This planetary fog creates the sense that darkness is approachable, a background to the real things in our lives. But what if we could remove the filter? What if we could step outside this thin shell of gas and look at the universe without the bias of an atmosphere? In 2021, and again with updated results in 2024, humanity finally looked at the truth from a position of relative clarity. The New Horizons spacecraft, the same probe that sent back the first close-up images of Pluto, is currently more than 5 billion miles from your home. Out there, the sun is no longer a blazing furnace. It has shrunk into a brilliant but distant point of light, 300 times dimmer than a bright room on Earth. The zodiacal light is gone. The airglow is gone. And from that vantage point, 5 billion miles away, scientists turned the spacecraft's long-range reconnaissance imager toward the emptiest, blackest patches of sky imaginable. They were looking for what is called the cosmic optical background, the sum total of every photon produced by every star and galaxy since the beginning of time. They found a darkness that is functionally absolute. The measurement was approximately 11 nanowatts per square meter per steradian. To put that number into a human perspective, imagine a child's nightlight in a dark hallway. The combined fire of every galaxy in the observable universe, reaching us across billions of light-years of history, produces a background glow that is 50 million times dimmer than that single nightlight. The universe is on fire, yet it is pitch black. This is the paradox that should haunt you. There are 200 sextillion stars in the observable universe. That is a 2 followed by 23 zeros, more stars than every grain of sand on every beach on Earth. It is more stars than the total number of sounds every human being has ever spoken in the entire history of language. Each one of these stars is a thermonuclear furnace, converting millions of tons of hydrogen into helium every single second, and radiating that energy outward at 186,000 miles per second. The cosmos is not merely sprinkled with light, it is theoretically saturated with it. There are stars dying in supernovas right now that briefly outshine their entire host galaxies. There are blue supergiants burning with a ferocity that beggars metaphor, and red dwarfs that have been shining since before the Earth existed. If you could tally the total energy output of every star currently shining, the number would be roughly 3 times 10 to the power of 49 watts. And yet, if you look up at the night sky, you see that the darkness is not the exception. The darkness is the rule. Between the visible pinpricks of light, there is a depthless, malicious blackness that dominates 99% of what you see. The darkness does not merely win, It wins by a margin so vast that calling it a competition feels dishonest. The fire is real, the stars are real, but for some reason the fire cannot banish the night. For centuries, this was considered a simple mystery of distance. We assumed the sky was dark because the stars were far away. But, as we will see, the math proves that distance alone should not save us from an inferno. If the universe were what we once believed it to be, eternal, infinite, and unchanging, then your night sky should be as bright as the surface of the sun. You should be living in an environment of 5,500 degrees Celsius, an inescapable wall of light in every direction. The fact that it is dark tonight is the universe's most profound confession. It is a message whispered across the void, telling us that reality is younger, stranger, and far more terrifying than we ever dared to imagine. It is a sign that the very architecture of our cosmos was built from separation and time rather than substance and light. If you enjoy deep investigations into the hidden architecture of reality, subscribe now. The investigation begins with a paradox that baffled science for centuries. To understand why the universe is black, we have to first understand the geometry of the inferno. Imagine for a moment that you are standing in the middle of a forest that never ends. In every direction you look, there are trees. Some are close, their bark detailed and rough. Others are farther away, appearing as thin, vertical lines. In an infinite forest, no matter which way you turn your head, your line of sight will eventually terminate on the trunk of a tree. You would not be able to see the horizon, you would only see a solid wall of wood. Now replace those trees with stars. If the universe is infinite, and it is filled with 200 sextillion suns, every tiny patch of sky should be occupied by a star at some distance. It doesn't matter if the nearest star in a specific direction is 1 billion light-years away. In an infinite universe, there is always another star farther out. This means that instead of the profound blackness you see when you look at the gaps between stars, you should be seeing the glowing surface of a sun. The entire sky, from horizon to horizon, should blaze with the average brightness of a stellar surface. Night should not exist. This is known as Olber's paradox, and the logic behind it is devastatingly simple and mathematically airtight. In 1744, the Swiss astronomer Jean-Philippe Lois de Chezeaux worked out the precise mathematics of this problem. He divided the universe into thin, concentric shells around the Earth, like the layers of an onion. A shell that is twice as far away as another has 4 times the volume, and therefore it contains 4 times as many stars. However, because of the inverse square law, one of the most brutal rules in physics, each of those stars appears 4 times dimmer. The two effects cancel each other out perfectly. 4 times more stars, but each one is 1/4 as bright. This means that every shell of space, regardless of its distance from your eyes, delivers the exact same total amount of light to your retina. If you stack an infinite number of these shells together, each adding the same dose of light, the total becomes infinite. The math was irrefutable. The universe should be a wall of fire, but you are sitting in a dark room. You are safe. You are cold. The universe is not a wall of fire. It is an abyss of vacuum where stars are rounding errors and light is a temporary failure of the darkness. The reason for this, the real reason the darkness wins, requires us to dismantle our most basic assumptions about the nature of time and the speed of light. We are living in a privileged, temporary window of clarity. We happen to exist during the one brief moment when the universe contains fire. We look up and assume that brightness is normal. We assume that the stars are permanent fixtures of a luminous reality. The truth is exactly the reverse. The universe is fundamentally a place of darkness that is occasionally and briefly interrupted by light. The darkness you see tonight isn't just the absence of something. It is the fingerprint of a cosmos that is younger and stranger than we ever imagined. The investigation into how that fire is being systematically extinguished begins now. To understand why the universe is black, we have to first understand the geometry of the inferno. Imagine for a moment that you are standing in the middle of a forest that never ends. In every direction you look, there are trees. Some are right in front of you, their bark detailed, rough and familiar. Others are farther away, appearing as thin, vertical lines against a hazy background. In a forest that stretches on forever, no matter which way you turn your head, your line of sight will eventually terminate on the trunk of a tree. You would not be able to see a horizon or a clearing. You would only see a solid, unbroken wall of wood. Now, replace those trees with stars. If the universe is infinite, as we believed for the majority of human intellectual history, and if it is filled with 200 sextillion suns, then every tiny patch of sky you look at should be occupied by a star at some distance. It shouldn't matter if the nearest star in a specific direction is 1 billion light-years away. In an infinite universe, there is always another star farther out. This means that instead of the profound blackness you see when you look at the gaps between the stars, you should be seeing the glowing surface of a sun. The entire sky, from horizon to horizon, should blaze with the average brightness of a stellar surface. The math on this is not just speculation, it is geometrically airtight. If the universe were infinite, eternal, and unchanging, your night sky would be 5,500 degrees Celsius, a literal wall of fire in every direction. You should not be able to see darkness at all. Night should not exist. This is the contradiction that haunted astronomers for centuries, eventually becoming known as Olbers' paradox. But before we look at why the paradox fails, we have to look at the men who walked directly into the trap. The riddle of the dark night sky has one of the longest intellectual pedigrees in the history of science, stretching back nearly 250 years before Heinrich Wilhelm Olbers even put pen to paper in 1823. The first person to confront the darkness directly was the English astronomer Thomas Diggers in 1576. Diggers was a revolutionary. He proposed that stars were not fixed to a single celestial sphere, as the Greeks believed, but were scattered outward through an infinite universe. Diggers immediately recognized the problem this created. If stars extended infinitely, why were the gaps between them dark? His answer was a reasonable guess for the 16th century. He assumed the most distant stars were simply too far away to be seen, their light too feeble to reach us. It was a sensible thought, but it was fundamentally wrong. In 1610, Johannes Kepler took up the question. Kepler looked at the dark gaps and reached a blunter conclusion. The universe must be finite. He argued that the darkness was simply the dark boundary wall enclosing a limited cosmos. Where there was no star, there was simply nothing. But the appeal of an infinite universe was too powerful for science to abandon. More than a century later, the celebrated Edmund Halley, the man who predicted the return of the comet, revisited the problem. He sided with Diggers, arguing that in an infinite universe, the light from distant stars would simply be too faint to register on our eyes. Halley's defense, however, was about to be dismantled by the most brutal rule in physics, the inverse square law. In 1744, a Swiss astronomer named Jean-Philippe Lois de Chazeau worked out the precise mathematics of the problem. He divided the universe into thin, concentric shells around the Earth, like the layers of an onion. Chazeau realized something remarkable happens when you do the math. A shell of space that is twice as far away as another has 4 times the volume, and therefore it contains 4 times as many stars. However, the inverse square law states that each of those stars will appear 4 times dimmer because brightness drops with the square of the distance. The two effects cancel each other out perfectly. You have 4 times more stars, but each one is 1/4 as bright. This means that every shell of space, regardless of its distance from your eyes, delivers the exact same total amount of light to your retina. The first shell contributes a certain amount, the 1,000th shell contributes the same, the 1,000,000th shell contributes the same. If you stack an infinite number of these shells together, each adding the same dose of light, the total becomes infinite. The sky doesn't just glow, it explodes with brightness. Chézeau's proof was elegant and irrefutable. It proved that distance cannot save you. In an infinite, eternal universe, the dimness of individual stars is always exactly compensated by the greater number of stars in the distance. By the time Heinrich Wilhelm Olbers wrote his famous paper in 1823, the paradox had been circulating for 250 years. Olbers proposed a new, clever solution. Perhaps there was absorbing material between the stars, dust or gas that blocked the light from distant regions. It was a brilliant attempt to rescue the infinite universe, but it was fatally flawed. The flaw was identified by John Herschel. If interstellar dust absorbed starlight for millions of years, that dust would eventually heat up. It would reach thermal equilibrium with the light passing through it, and once it did, the dust itself would begin to glow just as brightly as the stars it was trying to hide. You cannot hide light by putting obstacles in its path. The obstacles eventually become the sources. Every escape route has been sealed. Every clever workaround collapses under mathematical scrutiny. Dust does not work. Distance does not work. Even clustering stars into galaxies doesn't work, because if you repeat the shell argument with galaxies instead of stars, you get the same result. The logic is airtight. The conclusion is terrifying, and yet the conclusion is observably, obviously wrong. Stand outside tonight and look up. The sky is dark. Between the few thousand stars visible to your naked eye stretches a profound blackness that dominates everything you can see. This is not a subtle margin of error. It is a catastrophic failure of human logic. The paradox holds on one side, reality holds on the other. For centuries, nobody could figure out what had to break. But the breakthrough, when it finally arrived, came from one of the most unexpected sources in intellectual history. It didn't come from a telescope or a laboratory. It came from the mind of a poet who was obsessed with the ending of the world. The darkness you see tonight isn't a lack of light. It is a sign that our most basic assumptions about the nature of time itself are wrong. The investigation into how a poet solved the mystery that baffled the world's greatest scientists begins in the next chapter. By 1848, the scientific community had reached a dead end. They had the math, the elegant concentric onion shells of Chézeau that predicted a sky of fire. They had the observations, the undeniable cold blackness that you see every time you look up. But they could not bridge the two. The logic was airtight and the reality was obvious, yet they stood on opposite sides of a canyon that no physicist could cross. The breakthrough, when it finally arrived, did not come from a professional observatory or a prestigious laboratory. It came from a man known for Gothic horror, detective mysteries, and tales of the macabre. In February of that year, in a lecture hall at the New York Society Library, Edgar Allan Poe stood before a crowd of just 60 people and delivered a sprawling metaphysical essay he called Eureka. Poe was not an astronomer. He had no formal scientific training and no institutional credentials. His contemporaries mostly dismissed the work as the eccentric philosophizing of a writer who had wandered too far from his craft. Some even called it absurd. But buried within Poe's poetic prose was an insight so profound that that it would take professional scientists another half-century to independently rediscover it through formal mathematics. Poe looked at the dark gaps between the stars and realized something that had escaped the greatest minds of the Enlightenment. He reasoned that the only way to comprehend why the background of the sky is not a solid wall of light is to suppose that the universe has not existed forever. He wrote that the distance of the invisible background was so immense that no ray from it had yet been able to reach us at all. This is the first partial resolution to the paradox, and it is the most important piece of the cosmic puzzle. The sky is dark because the universe has a birthday. To understand why this solves the problem, you have to look at the clock that governs the cosmos. For most of human history, we assumed the universe was eternal, that it had always been here and would always be here. In an eternal universe, light has an infinite amount of time to travel. No matter how far away a star is, its light would eventually complete the journey to your eyes. Every line of sight would eventually find a star, and the sky would indeed be a wall of fire. But the data now shows that the universe is not eternal. It began approximately 13.8 billion years ago in an event we now call the Big Bang. This is established, confirmed science. And because the universe has a finite age, it places a hard limit on what you can see. This is where you must grapple with a number that the human brain was never designed to intuit. We speak about the speed of light as if it is instantaneous, but in the context of the deep cosmos, it is agonizingly slow. Light moves at 186,000 miles per second. To humanize that number, in the single second it took you to read that phrase, a beam of light could have circled the entire Earth 7.5 times. It crosses the 250,000-mile gap to the Moon in just over 1 second. It reaches the Sun in about 8 minutes. At these scales, light is a god. It is the fastest phenomenon in existence, a wall of velocity woven into the structure of space-time. But as you move further out, that god begins to look like a crawl. The observable universe spans approximately 93 billion light-years in diameter. That is not a distance you can hold in your mind, but you can feel its implications. Light that left the most distant visible objects started its journey approximately 13.8 billion years ago. Those photons have been racing toward us at 186,000 miles per second for the entire history of time, and they are only just arriving now. This creates what astronomers call the cosmic event horizon. It is not a physical wall or a barrier of matter, but a boundary defined by time and speed. Beyond a certain distance, the light from stars and galaxies has simply not had enough time to reach us. Those stars might be burning right now with a ferocity that beggars metaphor, but their photons are still in transit. They are millions or billions of light years away, still crossing the gulf. Until those photons arrive, those stars contribute absolutely nothing to the brightness of your sky. They are invisible to you not because they are dim, and not because something is blocking them, but because the universe is too young for their light to have completed the journey. When you look at the black spaces between the stars tonight, you are not looking at empty space. You are looking at unreached time. Every dark gap is a region of the cosmos where the news of a star's existence hasn't reached you yet. Darkness is the visible fingerprint of the Big Bang. It is the silence that remains because the universe has a birthday. Poe's intuition, which was formally calculated by Lord Kelvin in 1901, proved that a finite age means a finite amount of light. In a finite volume of contributed light, the shells of the onion do not stack to infinity. They stop. The paradox assumed an infinite number of light sources filling an infinite amount of time. Reality, however, imposed the harshest possible constraint. Information has a speed limit, and the clock is still ticking. This realization should change how you feel when you stand under a clear night sky. You are sitting in a privileged, temporary window of clarity. You are seeing the parts of the universe that have connected with you. But for every star you see, there are trillions more whose light is still in the mail, still racing across the void at 186,000 miles per second, destined to arrive at a version of Earth that may no longer exist. However, even this profound resolution, the birthday of the universe, is only a partial answer. If the universe was simply 13.8 billion years old and static, the combined light of the trillions of galaxies within our horizon should still produce a faintly glowing background, a cosmic twilight that would make the sky significantly brighter than what we actually measure. There is something else happening. There is a second mechanism that is actively draining the energy out of the light that does manage to reach us. The universe is not just young, it is stretching, and as it stretches, it is beheading the photons before they can hit your eyes. The investigation into the redshift wall and the deeper complication of expanding space begins in the next chapter. If you have followed the investigation this far, you might be tempted to think that the darkness is merely a temporary condition, a result of the universe being too young to have filled our sky with light yet. You might assume that if we simply waited long enough, billions or even trillions of years, the photons currently in the mail would eventually arrive, and the dark gaps between the stars would finally close up, transforming our night sky into that glorious wall of fire predicted by the logic of the forest. But this is where the investigation takes its most unsettling turn. Even if you could wait forever, the light will never arrive in the way you expect. The universe has a second, more aggressive mechanism for maintaining its darkness, a process that does not just delay the light, but systematically destroys it as it travels. This is the redshift wall, and it is the reason why the darkness is not just a delay, but an absolute and final victory. To understand why your patience will never be rewarded, we have to look at the fabric of space itself. For centuries, we treated space as if it were a fixed stage, a static container where stars and galaxies performed their work. But in 1929, Edwin Hubble confirmed something that fundamentally altered our understanding of reality. Space is expanding. This is not speculation. It is measured directly through the observation of distant galaxies. Space is stretching. It is growing between every point in the cosmos, every single second. And as space stretches, it carries a devastating consequence for the photons traveling through it. Imagine a photon as a tiny, vibrating packet of energy. This photon has a specific wavelength which determines its color and its energy level. A short, tight wavelength is high-energy blue or ultraviolet light. A long, loose wavelength is low-energy red or infrared light. As a photon leaves a distant galaxy and begins its multi-billion-year journey toward your eyes, it is traveling through a medium that is literally growing beneath it. Because the photon is woven into the fabric of space-time, it has no choice but to stretch along with the space it occupies. Its wavelength is pulled apart. The tight, energetic vibrations of visible light are drawn out into long, sluggish waves. The universe literally beheads its own photons, draining their energy and stripping away their visibility as they cross the void. Think of a rubber band with a wave drawn on it. If you pull the ends of that rubber band, the wave doesn't just move, it changes shape. It becomes longer. In the context of light, this length is everything. Energy is lost. A photon that left its home as a blazing, violet spark of radiation arrives at Earth as a feeble, invisible infrared ghost. It is technically there, hitting your instruments, but for all practical purposes, and certainly for your eyes, it is darkness. The scale of this destruction is cumulative and relentless. A galaxy at what astronomers call a redshift of 1 has had its light stretched to twice its original wavelength. This means every single photon it emitted has lost exactly half of its energy during its transit towards you. By the time we look at galaxies at a redshift of 10, objects we are now observing with the James Webb Space Telescope, the light has been stretched to 11 times its original wavelength. Blazing ultraviolet radiation, which would have blinded you if you were standing near its source, arrives at our telescopes as a faint, mid-infrared glow, detectable only by instruments cooled to near absolute zero to avoid being overwhelmed by their own heat. The universe is not merely failing to deliver its light, it is actively degrading it. This brings us to the most extreme example of this process, the brightest light the universe has ever produced. Roughly 380,000 years after the Big Bang, the universe became transparent for the first time. At that moment, the entire cosmos was filled with a hot, dense plasma that glowed with a temperature of approximately 3,000 degrees Kelvin. This was a blazing orange-white fire that saturated every cubic centimeter of existence. There were no dark patches then, there were no gaps. The sky was, for one brief epoch, a literal wall of fire in every direction. That radiation still exists. It was never destroyed. It was never absorbed. Right now, those ancient photons are hitting your skin from every direction. They are passing through the walls of your home and the roof over your head, but you cannot see them and you cannot feel them. Over the last 13.8 billion years, the expansion of space has stretched those once brilliant photons by a factor of roughly 1,100. That orange-white inferno has been cooled into a faint microwave whisper with a temperature of just 2.725 Kelvin, 2.725 Kelvin. Give that number its own space. It is less than 3 degrees above absolute zero. To put that in perspective, this background glow, the brightest event in history, is now significantly colder than the surface of Pluto, which sits at roughly 33 Kelvin. The universe took the most powerful light ever created and stretched it until it became a ghost of its former self, colder than a frozen rock at the edge of our solar system. But there is a final, even more terrifying complication to this redshift wall. In 1998, 2 independent teams of astronomers confirmed that the expansion of the universe is not slowing down, it is accelerating. Driven by a mysterious component we call dark energy, space is pushing galaxies apart faster and faster every single eon. This is not stable, it is getting worse. We are currently living through what we should consider a privileged window of clarity. Right now, we can still see the light from distant galaxies. Even if it is redshifted and beaten down, we can still measure the microwave whisper of the Big Bang. But because expansion is accelerating, the redshift wall is closing in. Galaxies that are currently visible will eventually be carried across our horizon at speeds that outpace light itself, redshifted into such extreme wavelengths that they will disappear from every conceivable instrument forever. This is the horror of what we might call cosmic Alzheimer's. The universe is not just dark, it is engaged in a process of information erasure. It is hiding its own crime scene, stretching the evidence of its history until it vanishes. Future civilizations born trillions of years from now will look up at a sky that is not just dark, but empty. The expansion will have carried every other galaxy beyond their view. The microwave background will have faded into total silence. They will conclude with perfectly logical but entirely incorrect reasoning that their single galaxy is the only thing that has ever existed in an infinite, unchanging void. They will never know about the Big Bang. They will never know about the 200 sextillion stars that once shared their sky. The darkness you see tonight is not just a lack of light. It is the early stages of the universe forgetting itself. It is a sign that the fire was never meant to last, and that the void is not just a container, but an active force that consumes everything we find meaningful. But even this, the systematic destruction of light, does not account for the sheer physical scale of the nothing that light is trying to fight. Because while light is being beheaded by expansion, it is also being swallowed by an inventory of nothing so vast that the numbers themselves begin to lose their meaning. The investigation into the terrifying precision of the 2024 New Horizons data and the landslide of darkness begins in the next chapter. To find the true measure of the abyss, we have to leave the neighborhood entirely. We have to escape the planetary fog of Earth, move past the Moon, past the red dust of Mars, and even past the gas giants that anchor our outer solar system. We have to travel to a place where the sun is no longer a source of heat, but merely the brightest star in a cold, silent sky. In 2021, and with even more definitive data released in 2024, humanity finally conducted the ultimate census of light. The instrument used for this inventory was the New Horizons spacecraft. You likely remember it for the stunning, heart-shaped nitrogen glaciers it discovered on Pluto in 2015, but its most profound contribution to science was actually what it saw after it left Pluto behind. Right now, New Horizons is more than 5 billion miles from your home, drifting through the Kuiper Belt, a dark, frozen graveyard of icy worldlets. At this distance, the spacecraft is 54 astronomical units away. To humanize that distance, if you were to look back toward the sun from the deck of New Horizons, the star that powers your entire world would be 300 times dimmer than the light in the room where you are currently sitting. The sun has effectively been demoted. This extreme isolation is exactly what the mission required. To measure the true darkness of the universe, you have to get away from the zodiacal light, the subtle, pervasive glow caused by sunlight reflecting off the dust particles that clutter the inner solar system. Inside the orbit of Jupiter, this dust creates a permanent cosmic haze that makes it impossible to see the real blackness of the background. It's like trying to see a single candle across a foggy field while someone is holding a flashlight in your eyes. But 5 billion miles out, the fog clears. The zodiacal light is gone. The air glow of Earth's atmosphere is a memory. From this position of relative clarity, scientists turned the spacecraft's long-range reconnaissance imager toward 16 carefully selected patches of the deepest, emptiest sky imaginable. They weren't looking for stars or planets. They were looking for the cosmic optical background, the sum total of every photon produced by every star and every galaxy that has ever existed since the beginning of time. They were looking for the ambient light of the universe. And what they found is both mathematically precise and existentially staggering. The result of the 2024 measurement was approximately 11 nanowatts per square meter per steradian. I want you to give that number its own space. Do not rush past it. 11 nanowatts per square meter per steradian. This is not speculation. This is a direct measurement of the absolute limit of visible reality. This number represents the inventory of everything. It accounts for the light of the 2 trillion galaxies we know are out there and the trillions of stars within each of those galaxies. Now we have to humanize that number because the human brain is not built to understand nanowatts or steradians. Imagine you are standing in a long, dark hallway at night. At the very end of that hallway, there is a single, small child's nightlight, the kind that produces about 1 watt of light. Now imagine the combined fire of all 2 trillion galaxies in the observable universe reaching us across 13 billion years of history. According to the New Horizons data, if you were to collect all that cosmic light into a single square meter, it would be 50 million times dimmer than that one nightlight. Think about that. 2 trillion islands of stars, hundreds of sextillions of thermonuclear furnaces, each burning with a fury that outclasses billions of hydrogen bombs every single second. The universe has been pouring this energy into the void for nearly 14 billion years. And the result, the total accumulated brightness of the entire history of creation, is 50 million times weaker than the dimmest light in your house. This measurement confirmed something that scientists had long suspected but could never prove until 2024. There are no hidden reservoirs of light. There is no mysterious extra brightness lurking in the gaps. When the team compared the measured light to the total light that should come from all the galaxies we can detect with our best telescopes, the numbers matched almost perfectly. The universe is exactly as dark as our most depressing models predicted it would be. The harsh reality isn't just that space is dark, it's the precision of that darkness. The inventory is complete. We have counted the photons and the results are in. The light is losing. It isn't just a close contest. The darkness isn't just a background. The darkness is a landslide. For every photon of light that manages to reach our instruments, there are quadrillions of miles of absolute, unyielding nothingness. The fire is real and the stars are real, but they are rounding errors in a calculation that is dominated by the void. This measurement from New Horizons represents the final collapse of our planetary intuition. On Earth, we are used to light being a dominant force. We turn on a lamp and the room is filled. We step into the sun and the world is saturated. Our entire biological history was spent in a localized anomaly where light is abundant and darkness is just a temporary shadow. But 5 billion miles away, looking at the data from LORRI, we see the truth. The ambient lighting of the universe is functionally zero. We are living in a universe that has been on fire for 13.8 billion years, and yet, if you were to stand in the deep void between galaxies, your eyes would detect absolutely nothing. The fire of 200 sextillion stars has failed to make a dent in the night. This inventory of nothing reveals that the architecture of the cosmos is not built from the things we can see, the stars, the planets, the galaxies. Those are the exceptions. Those are the brief, local failures of the darkness. The true substance of the universe, the part that accounts for 99.9% of the volume and the vast majority of the story, is the blackness itself. The darkness didn't just win the war for the sky, it was the only real player on the field from the beginning. But to understand why this landslide is so absolute, we have to look past the light and start looking at the geometry of the emptiness, because as vast as the distances between stars are, they are nothing compared to the colossal bubbles of nothing that define the large-scale structure of the universe. The investigation into the ocean of emptiness and the terrifying scale of cosmic voids begins in the next chapter. As you sit there, you are currently suspended inside an architecture that is defined not by what is there, but by what is missing. To this point, our investigation has focused on the failure of light, how the universe's fire is too young, too far, or too stretched to illuminate the night. But now we have to move beyond the behavior of photons and look at the actual geometry of the stage they inhabit. We have to confront a reality that is far more structural and far more disturbing. The universe did not accidentally end up dark. It is architecturally dark, built from a blueprint of separation where light-producing matter is the ultimate anomaly. To understand the scale of this emptiness, we have to start with the familiar. You think of your solar system as a family of planets huddled around a sun, but that is a localized illusion of density. If you were to scale the sun down to the size of a tennis ball sitting on a table in front of you, the Earth would be a microscopic grain of sand orbiting about 25 feet away. But to find the next nearest tennis ball, Proxima Centauri, you would have to travel roughly 1,200 miles. In every direction for those 1,200 miles there is nothing. There is no atmosphere to scatter light, no gas to glow, and no surfaces to reflect. There is only a vacuum more perfect than anything we can produce in a laboratory, a silence so total that the word empty fails to capture the physical reality. This is the environment inside a galaxy, the supposedly crowded part of the cosmos. The Milky Way contains up to 400 billion stars, but the volume of the space between them exceeds the volume of the stars themselves by factors of trillions. A galaxy is not a city of stars. It is an abyss of vacuum where stars are rounding errors, and you happen to be standing on one of those errors. But this is just the beginning of the scale escalation. When we leave the Milky Way and enter intergalactic space, the density of reality drops into a new tier of absence. Between us and our nearest major neighbor, Andromeda, there are 2.5 million light-years of essentially nothing. In interstellar space, you might find one atom for every cubic centimeter. In the intergalactic gulf, that density drops to roughly one atom per cubic meter. This is not speculation. This is what the data says when we measure the large-scale structure of the cosmos. If you could survive being placed at the midpoint of this 15 quintillion-mile chasm, your eyes would detect absolutely nothing. The Milky Way and Andromeda would be faint, unresolved smudges on opposite horizons, and the rest of the sky would be the deepest, most malicious blackness any conscious being could ever experience. There is no air to carry sound, no molecules to transfer heat, and no reference point to give you a sense of up or down. You would be adrift in an ocean of darkness that feels not just large, but specifically designed to ensure that no fire could ever meaningfully touch another. However, even these intergalactic gaps are small compared to the true masters of the cosmic architecture. When astronomers began mapping the universe in 3 dimensions, they expected to find galaxies scattered more or less evenly, like dust in a room. Instead, they found a web. We now know that galaxies concentrate along thin filaments and dense nodes, like a 3-dimensional net. And between those filaments lie the voids. These are the bubbles of nothing that dominate the volume of your universe. The most famous of these is the Bhuta's void, a sphere of absolute night so vast it stretches 330 million light-years from one side to the other. To put that number into perspective, a region of that size in a typical part of the cosmic web should contain thousands of galaxies. The Bhuta's void contains fewer than 60. If you were at the center of the Bhuta's void, you would be further from a significant concentration of matter than the distance between the Earth and the Virgo cluster. The isolation would be total. You could send a message at the speed of light, and it would take 165 million years just to reach the edge of the bubble you are trapped in. In every direction for 100 million light-years, there is simply nothing. No stars, no planets, no civilizations, just expanding vacuum growing colder and more diffuse with every passing second. This is the central structural truth that the transcripts often ignore. The universe chose to put most of itself into emptiness, not matter. Roughly 80 to 90% of the volume of the observable universe is void. If you could color-code every cubic light-year of the cosmos by what it contains, the overwhelming dominant color of the universe would be black. The filaments, the clusters, the trillions of galaxies, and the sextillions of stars we've discussed, all of it occupies a fragile minority of the space that exists. The fire is real, but the volume it must fill is so incomprehensibly larger than the volume it occupies that the fire's total output vanishes into geometric insignificance. We are living in a desert of vacuum with occasional, isolated oases of light, and those oases are being systematically pushed further apart. Why is it this way? This is not a random distribution. This is the result of billions of years of gravitational sorting. In the early universe, matter was almost perfectly uniform, but gravity is a separation engine. Slightly denser regions pulled in matter from their neighbors, becoming richer, while the slightly underdense regions lost matter and became emptier. Over 13.8 billion years, this process has concentrated light-producing matter into an ever smaller fraction of space, while surrendering the rest to an expanding, absolute night. This process is still ongoing, and it is accelerating. Driven by dark energy, which operates most freely inside these empty bubbles, the voids are growing. They are thinning, darkening, and hollowing out the universe from the inside. The harsh reality is that the darkness is not an error in the architecture. It is the architecture. You are sitting in a privileged, temporary moment of history where the lights are still close enough to see, but you are doing so from within a tiny, fragile thread of matter suspended in an ocean of nothingness so vast it makes the fire of 200 sextillion stars look like a whisper, fainter than nothing. But to truly understand why this structural emptiness is so terrifying, we have to stop looking at the stars and start looking at ourselves. Because the same absolute night found in the Bootes void isn't just out there in the deep cosmos, it is the very thing you are made of. The investigation into the intimate abyss and the darkness within your own atoms begins in the next chapter. Right now, as you sit there, you are experiencing the sensation of your own weight. You feel the pressure of your body against your chair, the solid floor beneath your feet, and the physical boundary of your skin against your clothes. You perceive yourself as a substantial, solid object, a localized pocket of matter in a universe that we have already established is mostly empty. We have spent the last few chapters looking outward at the ocean of emptiness, at bubbles of nothing like the Bootes void that stretch for 330 million light-years. But to truly grasp the terrifying reality of how dark space really is, we have to stop looking at the horizon and start looking at the hand you are currently using to hold your device. The most effective emotional trigger in this investigation is the realization that you are not merely a spectator looking at a dark universe. You are a participant in its architecture. The same absolute night found in the deepest cosmic voids is not just out there, billions of miles away. It is the very thing you are made of. You have likely heard the romanticized scientific sentiment that you are a temporary arrangement of stardust. It is a phrase often used to make the scale of the cosmos feel approachable, even poetic. And it is a measured, confirmed fact. The hydrogen atoms in the water that makes up 60% of your body were created 13.8 billion years ago in the Big Bang. The iron in your blood, the calcium in your bones, and the carbon in your DNA were forged in the thermonuclear furnaces of stars that lived and died before our sun was even born. You are, quite literally, the recycled ashes of dead stars. But being made of stardust does not mean you are made of light. It means you are made of the same structural emptiness that defines the vacuum of the deep cosmos. To understand why, we have to look at the atomic void. This is not speculation. It is established science. Every object you have ever touched, your own body, the device in your hand, the planet beneath your feet, is almost entirely made of nothing. Consider the structure of a single atom. We are taught to visualize them as tiny solar systems with a solid nucleus at the center and electrons orbiting like planets. But this visualization is a lie of scale. In reality, the distance between that nucleus and its electrons is staggering relative to their sizes. If you were to enlarge a single hydrogen atom until its nucleus, the central marble of matter, was the size of a marble sitting at the center of a major city's football stadium, the single electron would be a speck of dust orbiting somewhere near the outer walls of the stadium, or perhaps even in the suburbs half a kilometer away. The arena, the parking lots, the surrounding blocks, all of it is empty. Everything between that central marble and that distant speck of dust is a vacuum. It is the same absolute night found in the Buddha's void. In scientific terms, an atom is more than 99.999999999% empty space. This is a number that the human brain was never designed to process. If you have roughly 7 octillion atoms in your body, that is a 7 followed by 27 zeros, then 99.9% of the volume you occupy is a void. If you could somehow reach into your body and remove all of that empty space, every single human being currently living on Earth would fit inside the volume of a single sugar cube. The harsh reality is that your body is not a solid object. It is a ghostly arrangement of points suspended in a vacuum so thorough that it mirrors the intergalactic gulfs we discussed in the previous chapter. This raises a question that should challenge your most basic sense of reality. If you are 99.9% empty space, why do you feel solid? Why does your hand not pass directly through your desk? Why does the floor support your weight instead of letting you fall through the atomic gaps? The answer is not substance, it is force. The feeling of solidity is a localized illusion created by electromagnetic repulsion. As the electron clouds of the atoms in your hand approach the electron clouds of the atoms in your desk, they repel each other with incredible intensity. You have never actually touched anything in your entire life. You have only ever felt the microscopic push of one force field against another. You are a collection of force fields holding on to a vacuum. This realization transforms the darkness of space from a distant, abstract mystery into an intimate, personal condition. You are not in the darkness. You are the darkness held together by fragile, temporary forces. The emptiness is not what fills the spaces between interesting things in the universe. Emptiness is what the universe, and everything in it, is actually made of. Darkness is simply what that emptiness looks like. When we look at a cosmic void 300 million light-years wide, we feel a sense of existential dread at its scale. But that void is not a different kind of nothing than the nothing inside your own cells. It is the same blueprint. The universe is architecturally dark, built from a plan of separation where matter is a rare and temporary deviation from the norm. We are living through a privileged window of clarity where we have enough fire to see the web of the cosmos. But as we have seen, that fire is a rounding error. It is a brief chemical reaction running on a finite supply of fuel. Most people look at the night sky and see the stars as the primary actors, with the darkness acting as a passive background. This is the ultimate planetary illusion. The truth is exactly the reverse. The darkness is the canvas, and the stars are the interruption, an interruption that is almost over, cosmologically speaking. You are a part of that interruption. You are a temporary arrangement of stardust that has opened its eyes for a fraction of a cosmic second to look at itself. You are the part of the darkness that has become conscious enough to measure the void it is made of. This is the intimate abyss. The silence of the intergalactic chasm is the same silence between your own atoms. The malicious blackness 5 billion miles away is the same blackness that accounts for 99.9% of your own volume. We are small. The universe is enormous. And we are beginning to understand that the nothing we fear in the deep cosmos is the very substance of our own existence. But while the darkness within is silent, the darkness without is beginning to feel occupied. As we move from the geometry of the void to the behavior of the things that live within it, the mystery takes a darker turn. If the universe is full of fire and atoms, why is it so quiet? The investigation into the great silence and the possibility that the darkness is not just empty but dangerous begins in the next chapter. To this point, our investigation has been an inventory of physical absence. We have measured the failure of light, the stretching of space, and the hollow architecture of the atomic void. We have established that the universe is overwhelmingly, structurally dark. But there is a second kind of darkness that we have not yet addressed, a darkness that is not made of missing photons but of missing voices. This is the great silence, and it is the most terrifying property of the cosmic night. Right now, as you sit in the stillness of your room, you are being bathed in radiation from every corner of the sky. We have confirmed through decades of radio and optical astronomy that the cosmos is a medium saturated with information. We have mapped the afterglow of the Big Bang. We have recorded the death rattles of stars. We have even heard the vibrations of space-time itself. We have become extraordinarily good at listening to the noise of the universe. But when we listen for a signal, for even the slightest pulse of intentionality, the result is a vacuum so total it mocks the sheer quantity of fire the universe contains. Consider the numbers again, because this is not speculation. It is the fundamental data set of the Fermi paradox. There are 2 trillion galaxies in the observable universe. Within our own Milky Way, there are between 200 billion and 400 billion stars. Current data suggests that planets are essentially everywhere. Almost every star you see tonight likely anchors a family of worlds. If you take the most conservative estimate possible, if you assume that only 1 in a billion stars has a planet capable of supporting life, and that life only develops into an advanced civilization 1% of the time, the Milky Way should still be teeming with thousands of intelligences. Given that our galaxy is 13 billion years old, many of these civilizations should have had a multi-billion-year head start on us. By every law of probability and every metric of cosmic time, the sky should be a riot of communication. It should be crowded with the technological fingerprints of a populated cosmos, radio leaks, Dyson spheres, or the movement of massive engineering projects. And yet, after 65 years of intensive searching, we have found nothing. The darkness is silent. This silence is not a minor scientific footnote. It is a catastrophic deviation from what the math predicts. Scientists refer to this as the Great Silence, and for years we have comforted ourselves with the idea that the silence is a technical problem. We told ourselves that we simply haven't looked long enough, or that we are listening on the wrong frequencies, or that the distances are too large for any signal to survive the transit. But there is a darker possibility, an explanation that provides a chilling intellectual satisfaction while simultaneously creating a sense of profound unease. It is known as the dark forest hypothesis. To understand the dark forest, we must first abandon our planetary intuition about communication. On Earth, we assume that contact is a benefit. We assume that if we find another intelligence, we will exchange information, trade resources, and grow together. But in a dark universe governed by the harsh laws of separation we have already established, the logic of survival takes a different turn. Imagine the universe as a dark forest at night. You are a hunter moving silently through the trees. You know that there are other hunters in this forest, but you do not know their intentions. You do not know if they are stronger than you, or if they view you as a threat, or if they simply want to eliminate you to ensure their own future access to the forest's limited resources. In this environment, you have one primary directive: survival. If you find another hunter, you have no way of knowing for certain that they will be peaceful. Even if they seem peaceful now, the technological explosion means that a civilization currently less advanced than yours could surpass you in the blink of a cosmic eye, becoming a threat before you can respond. In a universe where distances are measured in light years and communication takes centuries, there is no such thing as a peace treaty that can be verified in real time. Therefore, any hunter who reveals their position, any hunter who lights a campfire or shouts into the darkness, has committed a fatal error. To reveal yourself is to become a target. To be detected is to be eliminated by those who have already learned the lesson of the forest. In this view, the Great Silence is not evidence of an empty universe. It is evidence of a disciplined universe. The sky is dark because the survivors have learned to stay hidden. The darkness is not a gap between bright living things. It is a shroud used by every advanced civilization to ensure they are not the next to be extinguished. This creates a terrifying recontextualization of the data we've discussed. When we look at the Boötes void or the intergalactic chasms, we shouldn't just see empty geometry. We should see a landscape where the Great Silence is the primary survival strategy. The darkness is quiet because it is dangerous. You are currently standing on a planet that has spent the last century broadcasting its existence to the rest of the forest. Our radio waves, our television signals, and our radar pulses are currently expanding outward at the speed of light, washing over stars and systems that we can only see as faint points in the night. We have spent 100 years shouting into the woods, assuming that the silence meant we were alone. We assumed the darkness was a vacancy, but the harsh reality is that the most terrifying property of cosmic darkness is the invisibility of its inhabitants. If the dark forest hypothesis is correct, then our current era is not just a window of clarity, but a window of extreme vulnerability. We have lit a fire in the middle of a dark forest, and we are now waiting with naive optimism for someone to notice us. The data shows that for every star you see, there are trillions of miles of absolute unyielding nothingness. But the silence within those miles is not a lack of a story, it is the story. The silence is the sound of every other civilization holding its breath, waiting to see what happens to the one species that was foolish enough to make a noise. As we continue to build instruments like the James Webb Telescope to peer deeper into the infrared ghosts of the past, we are essentially building better eyes to see into the forest. But as we look, we must realize that the silence we find there might be the most informative signal of all. The universe is on fire, and yet it is pitch black. It is crowded with stars, yet it is profoundly empty. It is statistically ripe for life, yet it is deathly quiet. We are small, and the universe is enormous. But as we are beginning to learn, the nothing we fear in the deep cosmos is not just a vacuum of matter. It is a vacuum of intent. The investigation into the last embers of this luminous era and the final cold ending of the stelliferous epoch begins in the next chapter. The investigation has taken us through the failure of light, the stretching of space, the hollow architecture of our own atoms, and the disciplined silence of a universe that may be full of predators. But there is one final property of cosmic darkness that we have not yet addressed, a property that is not defined by distance or geometry, but by the relentless unidirectional flow of time. We have treated the luminous universe and the one full of stars and galaxies as if it were the standard state of reality. We look at the 200 sextillion stars currently burning and assume that fire is the baseline of existence. But this is a planetary illusion. The data shows that we are currently living through a brief, anomalous flash of brightness in a timeline that is otherwise defined by total, unyielding blackness. This is not a pessimistic interpretation of uncertain data. It is the confirmed trajectory of the cosmos under the standard model of cosmology. The fire is not a permanent feature of the architecture. It is a temporary chemical reaction running on a finite supply of fuel. To understand the scale of this ending, we have to look at the inventory of the future. Astronomers, including Fred Adams and Gregory Laughlin, have categorized the history of the universe into distinct eras. We currently live in what is called the stelliferous era, the age of stars. It began approximately 1 million years after the Big Bang, when the first gas clouds collapsed under their own gravity to ignite the first nuclear furnaces. It is scheduled to end roughly 100 trillion years from now, when the last red dwarf in the furthest galaxy finally exhausts its hydrogen and fades to black. 100 trillion years sounds like a duration so vast it borders on the eternal. But in the context of the total lifespan of the universe, 100 trillion years is a rounding error. This is the harsh reality that our intuition cannot process. 95% of all the stars that will ever exist in the history of the universe have already been born. This is established, measured science. The rate of star formation across the cosmos peaked approximately 11 billion years ago, an era astronomers call cosmic noon. Back then, galaxies were forging new suns dozens of times faster than they are today. Since that peak, the cosmic factory has been steadily, irreversibly shutting down. Today, the universe produces new stars at roughly 3% of its peak rate. The fire is going out. The reservoirs of cold molecular hydrogen gas that feed stellar birth are being drained, heated, or ejected into the intergalactic void where they can never collapse again. We are not living in the morning of a bright universe. We are watching the tail end of the brightest epoch the cosmos will ever know. We are the occupants of a dying fire, huddled around the last glowing embers, convinced that the light is permanent because it is all we have ever known. To grasp the terrifying brevity of this luminous era, we must use a human-scale ruler. Imagine the total lifespan of the universe, from the first moment of the Big Bang to the final cold evaporation of the last subatomic particle, as a 100-yard football field. If you start at the first goal line where time begins, the stelliferous era, the entire age of stars, galaxies, planets, and life, would occupy a mark so thin that no human eye could resolve it. It would be a line thinner than a single atom on that 100-yard field. Everything else, the remaining 99.9999% of the field, is darkness. When you stand under the night sky tonight and look at the black spaces between the stars, you are not just looking at the background of the universe, you are looking at its destiny. The darkness is the default state. The fire is the exception, and the exception is almost over. What follows the stelliferous era is what physicists call the degenerate era. This epoch begins roughly 100 trillion years from now and stretches to 10 to the power of 39 years, a number that mocks the age of our current universe. During this time, the sky will be truly, functionally empty. There will be no stars. The only things remaining will be the corpses of stars, white dwarfs slowly cooling toward absolute zero, neutron stars, and brown dwarfs that never had enough mass to shine. In this era, the universe is a graveyard of cold matter. Occasionally, two white dwarfs might collide, triggering a brief, violent supernova that illuminates the surrounding void for a few weeks before fading back into the night. These are the last gasps of a dead epoch, rare flashes separated by trillions of years of absolute silence. But even the degenerate era is just a prelude. Following it is the black hole era, which continues until roughly 10 to the power of 100 years from now. By this point, all ordinary matter has decayed or been consumed. Black holes are the only significant structures left in the cosmos. They will slowly, painfully evaporate through a quantum process called Hawking radiation. A black hole with the mass of our Sun would take 10 to the 67th years to dissipate. The supermassive monsters at the centers of galaxies will take far longer. And then finally, the dark era begins. This is the final, eternal chapter of the cosmic story. No stars, no remnants, no black holes, no structure. Just elementary particles, electrons and positrons drifting through a featureless, ever-expanding void with vanishing density. The temperature approaches but never quite reaches absolute zero. The dark era has no end. It simply continues forever, growing colder and more silent for a duration that makes the age of stars look instantaneous. This is the law gap that changes everything. The universe was dark for 1 billion years before we arrived, and it will be dark for an eternity after we are gone. We have mistaken the prologue for the whole book. We look up and see fire and assume that light is the baseline of reality, but the measurements are in and the observations are complete. The cosmic optical background has been quantified by the New Horizons probe, and it confirms there is no hidden reservoir of light waiting to save us. The fire of 200 sextillion stars is not a victory over the night, it is a temporary failure of the darkness. This realization should shift your perspective of the night sky from one of comfort to one of profound existential weight. When you look at the stars tonight, you aren't just seeing light. You are seeing a dying resource. You are witnessing the final moments of a rare, luminous anomaly in a universe that is architecturally designed to be black. The darkness you see between the stars is the picture, and the stars are just the interruption. And the interruption is fading. The universe did not accidentally end up dark. It is structurally dark in its bones across every scale and every epoch. Light is what happens when gravity manages in rare and temporary circumstances to compress enough matter into a small enough space to trigger a reaction. Everything else, the overwhelming majority of space and the overwhelming majority of time, is the void. We are living through a privileged window of clarity where we have just enough fire to see the web of the cosmos before the expansion carries it all away and the fuel runs dry. The investigation into the physics is over, the structure is mapped, the mechanisms are understood. What remains is the final question. What does it mean to exist as a conscious observer inside an architecture that is dominated by an eternity of silence? The final existential beat and the resolution of the story begin in the next chapter. This investigation has led us from the domestic illusions of the earthly night to the terrifying precision of the 2024 New Horizons data. We have mapped the failure of light, the stretching of space, the hollow architecture of our own atoms, and the disciplined silence of a universe that may be full of predators. We have established that the universe is not a place where light happens to be losing a close race. It is a place where light was never going to win. Now we must confront the final property of this cosmic night, its meaning for those of us currently adrift within it. We are, quite literally, the most fortunate generation of observers in the history of the cosmos. We are living through what scientists call a privileged window of clarity. This is not a poetic sentiment, it is a measured, temporal fact. Because we exist 13.8 billion years after the Big Bang, we are in the only epoch of time where the universe's history is still readable. The fire of the first stars is still reaching us, the ancient afterglow of the Big Bang is still detectable, and the galaxies are still close enough to map. This is our forward momentum. While the universe is systematically erasing its own history, we are building instruments to capture the evidence before it vanishes forever. We are building the James Webb Space Telescope, which acts as a powerful infrared eye, peering through dust clouds to find the ghosts of the first galaxies, the tiny reddish smears that formed just a few 100 million years after the Big Bang. We are looking into what astronomers call the cosmic dawn, mapping the moment the universe first transitioned from opaque darkness to a state of transparency and light. But we are no longer limited to just looking. In 2015, we opened a new sense entirely. Using LIGO, the Laser Interferometer Gravitational Wave Observatory, we have begun to hear the universe. We are listening to the vibrations of space-time itself, detecting ripples produced by the most violent dark events in the cosmos, the collisions of black holes and the mergers of neutron stars. These events release more energy in a fraction of a second than every star in the observable universe combined, yet they produce almost no visible light. They happen in the absolute night of the deep void. And for the first time, we have the technology to listen to the tremors they send across the fabric of reality. We are racing against a clock that we cannot stop. Because the expansion of the universe is accelerating, we are heading toward a state of information erasure, a phenomenon some call cosmic Alzheimer's. Trillions of years from now, the expansion will have carried every other galaxy beyond the cosmic horizon. The light from those 2 trillion galaxies will be redshifted into wavelengths so extreme they will become undetectable by any conceivable instrument. The cosmic microwave background, the snapshot of our own origin, will have faded into total, eternal silence. Future civilizations born into that era will look up at a sky of perfect, featureless blackness. They will see only their own local stars. They will conclude with entirely logical but entirely incorrect reasoning that they are the only thing that has ever existed in an infinite, static void. They will never know about the Big Bang. They will never know about the 200 sextillion stars that once shared their sky. They will live in a universe that has successfully hidden its own crime scene. We are the ones who get to see the whole map. We are the ones who get to count the 11 nanowatts of the cosmic optical background. We are the ones who get to solve Olber's paradox. But this clarity comes with a weight of honest uncertainty. While the physics of the darkness are now clear, mapped by new horizons and calculated by the standard model of cosmology, the purpose of that darkness remains a vacuum. The data shows that the stelliferous era, the entire age of stars and warmth, is just a passing phase. If you laid out the universe's total lifespan on a 100-yard football field, the age of light would be a mark thinner than a single atom. Everything else, the 99 yards before and after that sliver, is darkness. This leads us to the final existential beat. For most of our history, we have viewed darkness as the absence of something, a gap in the picture, a void waiting to be filled by the real story of light and matter. But our investigation has proven the reverse. Darkness isn't the absence of a story, it is the story. The darkness is the canvas. The stars are merely the brief, temporary interruptions. We have spent centuries obsessing over the interruptions, but the harsh reality is that the blackness is the dominant structural condition of nearly all of space and nearly all of time. The darkness is the natural, default state of a universe built from expansion, separation, and finite time. This realization should not be a source of dread. It should be a source of profound equanimity. You are a temporary arrangement of stardust, a collection of atoms forged in the furnaces of stars that died before the Earth was even born. You are 99.9% empty space, a ghostly arrangement of points held together by fragile forces. You are not in the darkness. You are the darkness that has briefly found a way to hold itself together. And for one fraction of a cosmic second, you have become conscious. You are the part of the darkness that has opened its eyes to look at itself. In a universe that is 80% void, in a timeline that is 99% black, you happen to exist in the one brief flash of fire when it is possible to see the rest of creation. You are the species doing the investigation. You are the eyes of the void, looking back at the 200 sextillion stars and the 11 nanowatts of background glow, trying to make sense of the landslide before the lights go out for good. You are small. The universe is enormous. The distances are malicious. The expansion is relentless, and the darkness will eventually be total. But right now, you are here. You are sitting in a room, feeling the weight of your own weight, made of the same absolute night found in the Buddha's void. Yet, you are thinking. You are the only part of the darkness that knows it is dark. And that is the most interesting thing we know. The fire is real, the stars are real, but the darkness is the rule. We are the exception. And for one beautiful, terrifying moment, the exception is staring right at the rule. If this investigation has changed how you see the night sky, subscribe now. The story of the universe is still being written, and we are the only ones left to read it.